This work on collisions uses the work that we did in M1 and extends it further. Here we have two particles. The mass of the first one is 200 grams and the mass of the second one is 400 grams. This particle is moving in this direction at 5 meters per second. This particle is moving in the opposite direction at 4 meters per second, so there's a minus sign. The principle of conservation of linear momentum says that the total momentum beforehand equals the total momentum afterwards. So therefore we've got 200 times 5 plus 400 times minus 4 equals 200 V1 plus 400 V2. So that's 1000 minus 1600, so that's minus 600 equals 200 V1 plus 400 V2. Now you'll realise that we've got an equation here with two unknowns, V1 and V2, so we don't have enough information to solve this equation. What we can do is use a new concept called the coefficient of restitution, which will allow us to solve this equation. Now imagine tennis players and playing tennis on a hard court and then playing on a grass court. You'll realise that on a hard court the tennis ball will probably bounce higher than it will on a grass court. That's because the coefficient of restitution between a tennis ball and a hard court is much closer to 1 than a tennis ball on a grass court. But now imagine taking a golf ball to the hard court and comparing its bounce with the tennis ball on a hard court. The golf ball is more likely to bounce higher than the tennis ball is. That's because the coefficient of restitution between the golf ball and a hard court is closer to 1 than a tennis ball on a hard court. So the coefficient of restitution is a fraction between 0 and 1, and a perfectly elastic collision would take place if the coefficient of restitution is closer to is exactly equal to 1, and a perfectly inelastic collision would arrive if the coefficient of restitution is 0. So if we consider the speed of separation of two particles after the collision, that's going to be a smaller number than the speed of approach. And so this fraction, the speed of separation divided by the speed of approach, is called the coefficient of restitution. Consider what this means in a generic collision. Here we've got M1 U1 V1 for the first particle, M2 U2 V2 for the second particle. So the speed of separation is the difference between the speed of this particle and this particle. So we can say that E equals V2 minus V1. But the speed of approach is the difference between U1 and U2. So in this case it's U1 minus U2. So let's think of an example to describe that. The speed of separation is the difference between the speed of the second particle and the speed of the first particle. So this particle is moving away at 2 meters per second, this particle is moving at 1 meter per second, so the speed of separation is going to be 2 minus 1. They're separating by a difference of 1 meter per second. But now the speed of approach describes how this particle approaches this particle. This is initially going at 3, this is initially going at 5, so this is coming up to it with a relative speed of 2 meters per second. So in this example, E is a half. Let's go back to the original question. So this is where we got to by considering the conservation of linear momentum. We had this equation and we had two unknowns. So we clearly need some more information. So suppose in this situation we're told that E is 1/2. We can now use what we've just learnt to work out what V1 and V2 is. So E is the speed of separation, so that's v2 minus v1 divided by the speed of approach, which is 5 minus 4. So thinking about that, 5 minus 4 is 9. So this is coming in this direction with 5. This is coming this direction minus 4. So the speed of approach is 9. So this means that a half is v2 minus v1 over 9. So rearranging that equation, we get 9 equals 2v2 minus 2v1. So we've now got two simultaneous equations, this one and this one, which we need to solve in the normal way. And when we solve those, we get v2 is a half and v1 is minus 4. You might like to just work through that yourself, but basically we've taken this equation and this equation and solved them to get v2 and v1. And that's using the formula for the coefficient of restitution as well as the formula for conservation of linear momentum.